Okay. Okay, look. Pay attention, guys. This A is 3 in our example. And this B is the standard base que suppose que I select 10 como un logaritmo log. Do you remember when you put log and no specification of the basis because the base is 10? So 81 divided by logarithm base of 3. Then you put this in the calculator. How? You put this in the calculator. Suppose this is my display. Look. Because in my displays, I press, well, clear. I press this key, log. Okay, I press like that. Immediately you see log parenthesis, automatically open the parenthesis. And you put 81 and close the parenthesis. Divided by division. And you press again log. And you put 3 and close the parenthesis. Log 3, close the parenthesis, press enter or press equal, depending on the calculator, equal, boom, and you get 4. The answer is 4. And makes sense to get 4 because 3 to the 4 power is 81. Similar result we get if you're using a natural. Natural 81 divided by natural 3. So it's completely independent. The standard base que we use, you press ln key 81 divided by ln for 3. And you get exactly the same result, independent of the base key you change. Let me try again. ln 81, sorry, divided by ln 3. Press enter, bam, again I get 4. Do you understand very well the chain of base formula? Super good, super useful. Okay, now we are ready. We are ready in this moment. We are ready to solving. Remember the last class, I proposed you one exponential equation that we cannot solving using the traditional way. Now we are solving using logarithmic because we don't know logarithm, but we know logarithm around. Okay, suppose the classical example is, suppose, this is the example one, okay, using like a motivation example. 2 to the x power equal 3. Okay, this is the classical example in which you cannot express both sides using the same base. Okay. So how you solve that one? Apply logarithm. What kind of logarithm? Well, standard. The standard you apply, for example, log of 2x, log of 3. Don't forget the parenthesis, guys. You can apply ln. Yes, you can, of course. The answer doesn't change. But okay, you need to make a decision, I suppose. Let's do one example using common, another example we are using natural, and they are no difference. Okay, now you apply one more time the property number 7 to allow us this exponent go to the front like an x, the x time log of 2 is equal log of 3. My goal is, this is magic. Look at that. Look, see, you understand what you're doing. When you apply logarithm, it's like one transformation of the original equation. This equation, original, is exponential equation, this one. Now it's converted to linear equation because this is just a number and this is just a number. Okay, of course, it's a weird number, it's a irrational number, but you put in a calculator, right? So now you divide both sides by log of 2 And this cancel out. X is equal log of 3 divided by log. Okay, we finished. Well, no. Okay, this is the answer. This is the exact answer. But it's a little bit hard, the interpretation. Suppose in the problem that we see after, we see some application problem in the real life. And suppose it's talking about money. Just say, what is the answer, Professor? How much money? No, logarithm 3 by logarithm 2. No, nobody understands. So you need to put this in there. Okay, entonces now you try to find the approximation answer. Approximate answer. And always in the test, it's a specification how many decimal place. Suppose conventionally, but depende de test, depende de 4 decimal, 4 digit, 4 decimal place. So you put in a calculator. Come on, let's do it together. You put in a calculator, something like that, and you let me know what the answer is. I put in a calculator logarithmic of 3. Like that, logarithm of 3 divided by logarithm of 2. Okay, close the parenthesis, important, divided by logarithm of 2. Boom, I get the answer. Please help me in the chat. Type in the answer you get in your calculator. Okay, I want to see the chat.
1.5849.
No necessary chat. That means say that the answer is 1.5849. Let me copy everything. 6250. At least this is a 0.1 in my calculator. No, another calculator, maybe more sophisticated. You can set out the amount of digits. Okay. Say again. Say again. You talk to me or no? Okay. Everyone follow me? But I need 4 decimal place. 4 decimal place means is 1, 2, 3, and 4. If next digit is 6, is 5 or greater than 5, you round off. And you increase in this. So actually, my final answer is 1.5850. Okay, you increasing 49 plus 1 is 50. This is my final answer. Any question? Okay, this is the kind of exponential equation. The only possibility to get answer is using logarithm. Yeah. Noise. Who make a noise?
I'm shy. He
Dave,
text me.
Dave, you know? Okay. Edward. Okay. Do you follow me? Everyone follow me the idea? Good. Yeah. Who make a noise? Oh, let me see.
No, I don't want to text him, but I'm pretty sure if I don't text him, he won't text me.
Who is speaking? I cannot detect who is speaking. Come on, guy, putting off the microphone, okay? Microphone off. Okay, thank you. Okay, let's do another example. I want to erase everything. Okay. Example 2. And you help me to put in the calculator. Suppose this example, a little bit different, but not too much. Who make a noise today? Oh, noise. Every microphone I see totally. Wait. Diana Perez. Okay. I detected. Mute. Okay. Ready. Okay. In this case, another exponential equation. We need to use a mandatory logarithmic because it's impossible to do it in another way. Okay, so now the first step is isolate the exponential part. Divide by 5 both sides. We have 2 exponent 3x equal a over 5. Okay, ready to apply logarithm both sides. In this case, you apply natural because no log again. Because I need to make sure. Next, we apply natural. You apply logarithm both sides. You know, logarithm is 1-to-1 function. So one value of the x corresponds to one value of the y, no problem. So we have no extraneous solution, it's clear. And one more time, you apply the property number 7 and the exponent go to the front as a factor. Now my goal is x. You buy both sides by 3 log of 2. Divide both sides by 3 log of 2. Therefore, x alone is equal log of a divided by 5 divided by 3 times log of 2. Okay, this is my exact answer, but I want the approximate answer because I suppose this is a word problem, no? So let me explain how you put this in the display of the calculator. Pay attention, don't try. Okay, you clear the display. You put log, for example, log. So you put 8 over 5 and close the parenthesis because this logarithm at the top logarithm finish. Divided by, be careful because in this case, we have 2 guys in the denominator, 3 and logarithm of 2. If you put without parentheses, you make a mistake because you need to indicate, the calculator is a little bit stupid. So you don't indicate the order of operations, because the calculator do it wrong. So you open parentheses mandatory because you have 2 elements. You have only one, no. If you have 2 or 3 or 4, you open the parentheses and can close everything inside the denominator. Entonces, open the parentheses 3 times, press time after log of 2, and close 2 parentheses, the parenthesis, okay, log of 2. And you close this parenthesis, que is the argument of this logarithm, and you close another parenthesis que indicate us que finish the denominator part. Press enter, boom, and you get the answer. Please help me. I need help. Come on, participation. Activate the microphone. You say, professor is something, digit by digit. Idea, Michael.
0.260.
Okay, 0.2260. 4 digit. Perfect. Final answer. So Jasmine do that after the round off using 4 decimal place. Super. Any question? Any question?
No, Professor.
Okay, super. So we are the best. Let's continue with the more complicated problem. More complicated, more complicated, more complicated. Look. Okay, more complicated. Suppose this. How? This is super complicated. Example 3 is 0.3 raised to the 1 plus x is equal 1.7 raised to the 2x minus 1. Again, we have one exponential equation. It is impossible doing in the traditional way. And the only possibility we have is using logarithmic. In this case, I want to illustrate using natural because it's the same guy. You have two standards, common and natural. You use either, and the answer doesn't change. It's magic. Then you apply ln both sides. And using one more time the property number 7, the exponent goes to the front as a factor. Well, in this case, non-factor is a algebraic expression, but it's okay. It's 1 plus x times ln of 0.3. Here we have 2x minus 1. I put the parenthesis intentionally, right? Because this is a number. So logarithm of 0.3, logarithm of 1.7 is just numerical value, no? And this multiply everything inside the algebraic expression to go to the front. Okay, this is the application property 7 of the logarithm. Que allow us to convert from exponential equation to a linear equation. This is a linear equation. And this linear equation we solving exactly the same we are doing in intermediate algebra. Because this is just a number, and this is just a number. Okay, we can compute in the calculator, of course, so we have no problem. You apply now distributive property, you multiply this and this, this and that, and we have natural logarithm of 0.3 plus x times natural logarithm of 0.3. This is the situation in the left-hand side. The situation in the right-hand side is similar. You multiply 2x times natural logarithm of 1.7 minus natural logarithm of 1.7 times -1 gets just -1. Okay, what is my goal? Well, my goal, remember, is x. I need to manipulate algebraically this equation in order to isolate the x. Therefore, I propose you, for example, there are many ways to do that. This logarithm do not contain x, I left here on the left-hand side, plus ln 1.7 guy bring to the right, to the left. Look, this guy I bring to the left. This no. This is stay in the right hand side, and this I bring to the right hand side. Okay, this is exactly the same we are doing in elementary intermediate algebra. You move the term that contain x one side, the other term that do not contain x to the other side. Finally, when I copy this exactly the same repetition, bring down. And you factor out x is 2 natural logarithm of 1.7 minus natural logarithm of 0.3. Wow, now I'm going to isolate the x. You divide both sides by 2 natural logarithm of 1.7 minus natural logarithm of 0.3. Okay. Entonces 2 natural logarithm of 1.7 minus natural logarithm of 0.3. This is cancel, of course. That was the intention. And my final answer is then natural logarithm of 0.3 plus natural logarithm of 1.7 divided by 2 times natural logarithm of 1.7 minus natural logarithm of 0.3. It is 6. Okay? That's it. No. Because look like complicated. Maybe when you are doing, you try to put in the calculator, you make a mistake. However, my recommendation is always when you have several logarithm, you condensing. Remember the property number 5, you apply here, and the property number 6, you apply here, and 7, why not? 6 and 7 together. Okay. Listen to me. I know when you have two logarithms, you adding is equivalent to say, look, my recommendation, highly recommendation, condensing the logarithm before putting the calculator. You put only one logarithm, not two. No. And inside you put the multiplication 0.3 and 1.7. You put in my calculator, 0.3 times 1.7, boom. The answer is 0.51. So this is equivalent to this two logarithm, que is a little bit complicated, at least for me. Put in the calculator. Entonces, now another possibility is condensing here, but in the condensing in the bottom, you have 2 as a factor, you put like exponent, it's 1.7 squared, divided by, because of subtraction, 0.3. And everything inside the argument of this. Just in case, I put 1.7 square, 1.7 is square power 2 divided by 0.3. Oh, the answer is, look, natural logarithm of 0.51 divided by natural logarithm of 9.63 repeated is the answer I get that. Okay. Entonces now you put this in the calculator. How? You put this in the calculator. How? Remember, this is the display of our calculator. In this example, I select natural logarithm. Why not? ln. ln what? ln 0.51. Close the parenthesis, division. 0.51. Close the parenthesis, division. And ln again. In this case, a little bit confused. Entonces, bueno, okay, 9.63. You put several 3. Okay, it's not important. 4 decimal place. Okay, entonces 9.333. 3, one more 3, 4 decimal place. And you close the parentheses, press enter. Okay. You get the answer?
Negative 0.2973.
Okay, super. 297, what? 3?
3.
3,
Yes,
okay.
3. Because it 2, but like after it's a 5, so you add 1, 3.
Very good. Okay, super. This is the answer. Exactly the same, the answer I have in my paper. Well. Let me analyze why. What is the reason, professor, that the answer is negative? It's possible that the answer is negative? Yes, it's possible the answer is negative because remember, the range of the logarithm function is all real. Some logarithm is positive or some logarithm is negative. But let me try to understand in detail what is the reason it's negative. Look, this is the relationship between this number, this number is 0.51 is less than 1. And remember the base of this logarithm is e, and e is 2.51. 7, 1, 8, something, no? Bam, 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 bam. But it's greater than 1. It's greater than 1. So they are contradiction. Look, this is less than 1, and this is greater than 1. So we're expecting negative value in this logarithm. However, in the second, no. Because in the second is 9 point something is greater than 1. The base is greater than 1. There are no contradiction to say positive. So the responsibility to be negative is because the top are negative. You understand this? Look like complicated this example? Too long? Or no? You understand very well or no? Answer me. Yes, no, no. Confusing.
Yes, Professor. Clear.
Okay. Okay. By the way, you are Anlan. Who's speaking?
Yes.
You are good. You are good, student.
Thank you.
Okay. Entonces, no problema. Let's move on to another example. Boom.
Yes.
Okay, go ahead. This is a little bit weird. Example. Look. This is 4 to the x minus 10 times 4 to the minus x equal 3. This is an exponential equation, but it's a little bit weird because we have 1, 2, 3 terms. But don't worry, look. The first thing you should do is eliminate the negative exponent. Eliminate the negative exponent. How you can eliminate? You multiply the entire equation, multiplication by 4 to the positive x, because I know that when you multiply this guy time 1 by 1, this, and this, the negative exponent is eliminated. Okay, you multiply, let me copy here, 4 to the x times 4 to the x is 4 to the 2x. Because x plus x is 2x, ¿no? Entonces 4 raised to the 2x, que es equivalent to say x squared. Make sense or no? Because the rule of the different levels of the exponent is multiplication. Minus 10 times something. This is 4 to the minus x times 4 to the x positive, is the multiplier that I defined at the beginning, is 4 to the 0, because minus x plus x is 0. And for any number or expression raised to the 0 power 1, so it's just 10. Stay like that, disappear. This is the intention. Well, this is the fundamental reason I multiply by 4 to the x, because I know that negative and positive endorse each other. So, and the last, no, the last is 3 times 4 to the x. Oh, fantastic. At least I eliminate the negative exponent, no? So this equation we are doing now is equation similar to the idea that we discussing in the chapter 1, in which you have one expression, is this. And you have the same expression here, but the first one is raised to the second power, and the next no. Is to the 1 power, no? Because nothing. This is a typical equation, is called a quadratic form. Do you remember that? Quadratic form. And for solving any quadratic form equation, we use an auxiliary variable, KU. And you declare 4 to the x because you take always the expression that contains the smaller exponent. So this is immediately I try to do my best to rewrite this equation using the auxiliary variable u. This is u squared, look at that, minus 10, okay, equal 3u. Wow. This equation is easier, and by the way, it's a quadratic equation. Look, u squared minus 3u minus 10 equal to 0. I put in a standard 4. Yeah, I solved this equation. That's it. Maybe using quadratic formula or by factorization. I suppose that factorization is easier because the combination is, let's see, I suppose que 5 and 2, no? Because 5 and 2 times 2 is 10, and somehow 5 minus 2 is 3. Yes, and the sign is negative and positive. Classical factorization. Okay, you separate into linear equation. You 5, and you separate in another linear equation with negative 2. And this is the answer. No, of course, no. We found the value of the auxiliary variable u. But I need to state the connection between u and x. Okay, I know what the idea. This is the formula of the connection. So basically, I rewrite this. I split the board into parts. For u5 and for u negative. Entonces, 4x equals 5. Wow, look at that. This is easier. Exponential equation. 4x equals minus 2. This is also easy exponential equation. And what is the only possibility we have to solve this exponential equation? Well, using logarithm. What kind? In my paper, I use a natural. I don't know why. So I apply natural logarithm of 4x equal natural logarithm of 5. One more time, you apply the property 7 to allow me to put the exponent in the front. And finally, divided by ln for both sides. Okay. I did that. Now x is equal natural logarithm divided by natural logarithm 4. Entonces, as always happen, this logarithm, guys, is irrational number. Is irrational number. Entonces, see, I asked you what the exact answer. This is the exact answer, but no. Normally, I need the approximation, and the approximation is indicate using that symbol. Approximate answer. You put in the calculator this. Is natural logarithm of 5 divided by natural logarithm of 4. Help me, please. And using again
1.1610.
10. Like that. Everyone is agree?
Yes, because the 6 rounds out the 9.
Okay. Then this is my first solution. Let's see the second solution. Oh, the second solution, something's wrong. Something is wrong. Because I know very well that exponential function never is equal negative. See, I remember quickly, the exponential function look like that. The exponential function has the horizontal asymptote at y equals 0. Entonces, the thing I try to investigate que this exponential function, que es 4 to the x, is equal minus 2. And minus 2 represent the horizontal line here, y equal minus 2. This is completely wrong. Suppose que I don't know, or I don't remember this idea. No problema. We try to do in the same way of this. So apply logarithm on both sides. You put the factor in the front. Okay, noise. Divided by ln of 4. Again, same procedure. It's identical. It's the same. But where's the problem? The problem is when you try to put in the calculator this. Come on, try putting in the calculator this. And you see surprise. Natural logarithm of negative 2 divided by natural logarithm of 4. I try in my calculator. And you let me know what you see, the matches you see in the calculator.
I get an error saying it's
Error.
not real answers.
Oh, error. because it's complete out the domain. In my calculator, let me try. A natural logarithm of -2 divided by natural logarithm of 1. Boom. It's similar, is domain error. Domain error. And this is logical because logarithm of negative number is totally illegal. It's illegal. Therefore, we have only one solution. That is boom. End of story. Final answer. Everyone follow me? Clear? Confusing?
Clear.
Excellent. Okay. Now we continue, but we are discussing another kind of equation. It's a logarithmic equation. Logarithmic equation. Now, okay, it's important, extremely important in the word problem, in the application we study maybe next class. Okay. Okay, the topic today now is logarithmic equation. Logarithmic equation. I enlarge a little bit and highlight because it's important. It's important. Okay, logarithmic equation. Let me start for one elementary example. Example 1. Okay, is logarithm base 3 of x plus logarithm base 3 again of x minus 24 is equal 4. Okay, typical logarithmic equation. You see, so far we studied the traditional exponential equation. Okay, you solve it using the idea. You try to manipulate both sides in order to solving. We study after another case impossible, and we use a logarithm. So I use a logarithm to exponential, but this is completely different. This is logarithmic equation. This equation can contain logarithmic, right? Entonces, the important thing is que you know que the domain of the logarithm is not all real number. There's only non-negative numbers. That's 0 or non-negative, no, positive. It's more clear to understand. Only positive. But inside the argument, you plug in only positive numbers. No 0, no negative. Error. You see the situation. Entonces, es mandatory to check it. This is similar to the equation that we solved in the chapter 1. Do you remember radical equation? Okay, when you solve the radical, something, not always, but sometimes we get the straight solution. In this case, yes, sometimes you get the straight solution. It's a mandatory step. And the solution for the logarithmic equation is when you get the solution, you verification this solution, this potential between quotation mark and the original equation and verifies a true statement or no, right? Let me explain step by step. The first step is condensing the logarithm in only one logarithm. Well, in this example, you have only 2, because you have 2, 3, 4, 5 logarithms. You condense it in only one. In this case, using the property number 5. Why? How do you know the 5? Because it's plus. Si es minus, it's property number 6. Now you're condensing multiplication of this expression and this expression. Okay? Entonces es like x times x minus 24 together time multiplication, and this is the argument of the logarithm. You put the bracket or you put another parenthesis, it's the same. So the first step always is condensing several logarithms, 2, 3, 4, 5, and only one. Boom. Okay, super. After, what is the second step? Well, the second step, to see much better the equation, I propose always conversion to exponential. So you put an arrow like that. And the arrow you put conversion to exponential. Yeah, I understand very well the action you are doing. Okay, let me try to do. What's the base? Oh, the base is 3. So this is small 3, I put big. What is the exponent? Now, the exponent is the answer for the logarithm gets 4. Is equal the rest, que the argument gets x times x minus 24. Everyone understand the conversion? Logarithmic statement to exponential statement? However, it's easy because 3 to the 4 power is 3 times 3 times 3 times 3 is 81. So it's 81 is equal x minus 24. Why not? You apply distributive property here. And we have x squared minus 24x. Wow, this looks like quadratic equation. For solving this quadratic equation, I try to put in a standard form. X squared minus 24x minus 81. I move 81 to the right hand side, and in the left hand side we have nothing, and nothing is 0. Okay, so we have this quadratic equation. Okay, this is nothing for us, too easy. We can solve it by factorization, but in this case, no, it's not too trivial doing by factorization. I don't know if you see or no the combination, but okay. And you try 2 seconds. If you don't see the combination, you apply the quadratic formula, ABC. ABC is A is 1, B is negative 24, and C is negative 81. Boom. I put a formula, minus B, plus and minus, square root, B squared minus 4AC, divided by 2. Entonces we have minus of the formula, it's a 24 positive, no? Double negative, no? This negative and this negative together, plus and minus, square root, negative 24 squared, minus 4, multiplication by 1, is a multiplication by negative 81, divided by 2 times 1, because A is 1. Okay, now we're focusing in the expression inside the radical. Of course, we're using calculator because it's complicated by hand. And this is not our problem now, arithmetic. We focus on this. Negative 24 squared is 24 squared.
576 because multiplying both negatives becomes positive.
Super. Likewise, 4 times 1 get 4, times 81, 81 times 4, 81 times 4, 81 times 4. Help me, please. Nobody help me?
It's 324.
Positive or negative?
Positive.
Exactly. Because double negative, I can see. Now adding both. Is that 900? And square root 900? Exactly. 30. Okay, so far we have the 24 plus or minus 30 divided by 2. Let me separate into pieces. 24 plus 30 divided by 2 and 24 minus 30 divided by 2. Okay, this is 54, no? 54 divided by 2 is 27, no? I guess so. And this is minus 6 divided by 2 is negative 2. Boom, boom. It's a solution, but this is the solution. Okay, I don't consider it like a final answer, because remember, we need to check in the original part. So this is super important in this kind of equation, logarithmic equation, the checking part. Checking for of x equal 27. Let's do 27 first. I'm plugging in the original equation. So logarithmic base 3 of 27 plus logarithm of base 3 of 27 minus 24 should be 4. I need to prove this statement. I need to prove this statement. Okay, let me make a zoom to see much better that part. Okay, let me erase this. Okay. Well, this is logarithm base 3 of 27 plus logarithm base 3 of 27 minus 24 is 3 equal 4. There are many ways to do this. By hand or calculator. By hand or calculator. Let me try by hand. By hand is easy because look, I know the property number 1. We just studied the A property of the logarithm. Property number 1 say the logarithm, no, property number 2, sorry. Logarithm of the any base of the same number is equal 1. And this is one particular case, 3. So this is 1. So basically, logarithm of base 3 of 27 plus 1 equal 4. Do you follow me? Logarithm of base 3 of 27 is equal 4 minus 1 is 3. And this statement is true or no? Okay, we continue by hand or calculator. In this moment, if you feel you put in a calculator and you put in a calculator, for example, chain base is logarithm standard of the 27 divided by logarithm base 3, no? And the answer should be 3. Check it out, please. It says logarithm 27 divided by logarithm 3. Boom, I get 3. This is true. This is one possibility. Another possibility is, I explained several possibilities because we have more options. Suppose I want to prove que logarithm base 3 of 27 of 27. I have no idea. You put x and you change this to exponential. It's obvious that the base is 3. This 3 is this. It's obvious that the exponent is, I don't know. And the answer is 27. And 27 is 3 to the third power. Because 3 times 3 is 9. 9 times 3 is 27. And we have two exponential, same base, therefore the conclusion is x equals 3. We get the same conclusion. By hand? In this case, no. But in this case, no. The calculator is universal. The calculator is always possible. Help us to checking and compute the any logarithm. Okay, but I forgot -3. Oh, but -3 is a stupid solution. Why? Because when you try to checking for -3 and you plug in here -3, look, you see the logarithm of the negative number is impossible. Therefore, no. The only solution that we have in this problem is 27. Done. Any question, guy? Okay, there's a different step. Step 1 is condensing. So you have 2, 3, 4, 5 logarithms, you condensing only one. After, to see much better, you express in exponential. Now, after the exponential, well, you'll get quadratic equation or no, or linear equation, maybe, depending on the problem. You solve it using algebra, and finally, don't forget verification. The potential solution into the original equation to verify it's true. This is a mandatory step in the logarithmic equation. Any question? Clear or confusing? Let me see opinion. Opinions. Diana. Hi. Diana. Okay, any question? Everything is okay, it's clear? Clear or no?
Clear.
Okay. Let's continue. Another example. Logarithmic equation. Okay. This is easy, in my opinion. Logarithm base 2 of 3x minus 2 minus logarithm base 2 of x minus 5 equal 4. Es similar. What are the only differences? Es que es minus. Entonces, you need to apply the property number 6, not the property number 5. Property number 5 apply when it's plus here. The connection in between the logarithm, but the connection is negative. Si es negative, entonces property number 6. And property number 6 also condensing this logarithm in only one, but the only problem is now division. We put in the top the positive guy, and you put in the bottom the negative guy. And don't forget the parentheses enclose everything that belongs to the logarithm argument equal 4. This is my new equation. Wow, fantastic. I like that. Now, this is a crucial moment in which you apply the conversion to exponential. You are doing exactly the same in the test. You put the arrow and you put conversion to exponential, and that's it. Let's do in the conversion. The conversion is the base is 2. This big 2, this is small 2. The exponent is 4. And it's equal the rest, is 3x minus 2 divided by x minus 5. And this new equation actually is no exponential because 2 to the 4th power is 16. It's 2 times 2 times 2 times 2, 4 times is 16. So this is my new equation. Look, my new equation is 3x minus 2 divided by x minus 5 equals 16. Boom. Super easy, super easy, super easy. I propose you for solving this equation, apply cross multiplication. Okay, entonces 3x minus 2 times 1 equal 16 times x minus 5. The rest is algebra, classical algebra, that you know very well. So you multiply, distribute here. This is 16x minus 80 is 16 times 5. Okay, so far my equation is 3x minus 2 equals 16x minus 80. Let me try to do my best. Is okay. For example, I propose use this 16x stay here, print out, minus 3x. I move to right. This negative 2 stay, plus 80. Then move to the left. Now you combine 78 and it's 13. Divided by 13 both sides. The answer is 6. But I need to verification this solution. See, this solution doesn't work because we have only one. The equation have no solution. See, the solution work, well, the equation have that solution, que es the unique solution. To check in that, you plug in 6 into the original equation. Look, be careful. 3 times 6 minus 2 minus logarithm base 2 of 6 minus 5 equal 4. I need to prove that this statement is true. See, this is false, the solution doesn't work. Okay, multiplication. 3 times 6 is 18. 18 minus 2, 16. So basically, logarithm of base 2 of 16 minus logarithm of something, base 2 of 6 minus 5 of 1. Wow, I know very well the property number 1 que the professor explained me que logarithm of 1 is always 0, regardless the base. Property number 1, logarithm of any base of 1 is always 0. So this guy is 0, it's gone. I need to prove que logarithm of base 2 of 16 is equal 4. Okay, in this case, we can do that using calculator or by hand. They do it in both ways. In the real life, you decide what way you prefer. In a calculator, I put in a calculator something like that. Of course, the calculator have no logarithm of base 2. So I need to change the base to a standard. I put logarithm of 16 divided by logarithm of 2. And press enter. Let me try to do it in my calculator, my own calculator. Clear display, log 16 divided by log of 4.
Yeah, it gives you 4.
Exactly. Exactly, 4. Es the conclusion, confirmation. 4 is this 4. This statement is true, no problema. Suppose the student no have calculator, but you need to have calculator to pass this class. But some students prefer another way. Logarithm base 2 of 16, I have no idea what is the value. You convert to exponential. The base is 2. The exponent I don't know. And it's 16. But I know that 16 is 2 to the 4 power. It's 2 times 2 times 2. Therefore, x equals 4. Again, we prove que is true the statement. And the solution is fantastic. The solution is super. It's the solution of our problem. 6. Any question? Any question? Any question? Okay. Let me say something. I teach in this class, not only for you, sino another class, que es no mini term. Mini term, remember, is a week. I teaching in 16 week. It's a coincidence. I teach in this class, exactly this class, yesterday, in the evening. It's in the evening, our class. Okay, entonces, do you see how fast you are doing? In a week, this class in the morning is exactly the same of the class in the evening, MAC1105, in 16 weeks. So I did. Of course, our class is 3 times per week, and it's long, almost 2 hours. This class is 2 times per week. So another MAC1105 is 2 times. It's a Tuesday and Thursday, and this is 1 hour. Okay, but you know, it's a coincidence. One more example. Suppose logarithm base 14 of x plus 5 is equal 1 minus logarithm base 14 of x. Okay, we have to solve in this logarithmic equation. Now, pero the professor explained me que the first step is always condensing the logarithm. Okay, but in this case I cannot because one logarithm is in the left hand side, another is in the right hand side. Okay, I bring to the same side the logarithm of base 14 of x plus 5 plus logarithm of base 14 of x is equal. Wow, this equation is equivalent to the original. Okay, nice. Now we are ready to condensing. And only one logarithm. Logarithm of base 14 of the multiplication x times x plus 5. Don't forget the parenthesis or bracket to enclose everything. This is the argument of the logarithmic function, equal 1. Okay, crucial moment to conversion to exponential. The base is obviously 14. I put big 14. This 14 is this 14. The exponent is 1. Oh, when exponent is 1 is invisible. You don't need to put anything. Equal the argument of the logarithmic ethics. Okay, this is my new equation. Actually, it's not exponential, it's quadratic equation because you apply distributive property x squared plus 5x. I try to manipulate, putting the standard is x squared plus 5x minus 14 equal to 0. Wow, fantastic. I like that. Okay, we're focusing on this solution of the quadratic equation. I know that you have no problem. You are expert doing that. Okay, I suppose que by factorization is possible because the combination is 7 and 2. 7 and 2 together, 7 times 2 is 14, 7 minus 2 is 5. Okay, what sign? What sign? Plus 7 and minus 2. We break it down into linear equation. The first one, the solution is -7. And the second one is positive. Okay, you know, the negative solution doesn't work. Not always, guys, depending on the problem, but it's obvious in this problem, no. Because when you blow any -7 here, it's obvious it's out that this solution is stupid. Now I want to prove, verify, if it do work or doesn't work. Logarithm of base 14, so the checking part, at x equal logarithm by 14 of 2 plus 5 should be equal, in the original, 1 minus logarithm of base 14 of 2. Wow, I need to prove this. And the challenge is I do by hand, I do a calculator, well, or combination of both. Okay, this 2 plus 5 is 7. So I need to prove that logarithm of base 14 of 7 is equal 1 minus logarithm of base 14 of 2. Oh, much better, much better. Logarithm of base 14 of 7 plus, because I move another logarithm. What is the intention? The intention is condensing. Is equal 1. And you condensing one more time using the property number 5. The property number 5, remember, say that when you have two logarithms plus, it's the multiplication of the argument. There's a logarithm of base 14 of 7 times 2 is 14. Wow, amazing. Now, I know the property number 2 can say que logarithm of the any base when the argument is the same as 1. Entonces, 1, y I prove that. Super true. That means that the solution 2 is good. Solution 2 is good. The solution is perfect. Wow, any question? Okay, we are doing logarithmic equation, guys. This is my goal today. Next time, we start in applications. Applications. real life problem application. Okay. So far it's okay. Everyone follow me? I am doing too fast. You lost something? No?
Everything is good, Professor.
Everything is good. Thank you. Okay, one more complicated. Wow. Why is complicated? It's complicated because this equation that I want to write now is weird. Why is weird? Because one logarithm of the base is 2 and another logarithm of the base is not 2, it's 8. I never see before this idea, because normally the most common case is when the base is the same, because it's possible to apply the property 5, 6, or 7. No, this is property is valid only when the base is the same. When the base is different, the only property that we can use is the property number 8, is the change of base formula. Let me copy here. The change of base formula. Okay, the only possibility we have in this example, because this is the only formula that allows us to change the base. I want to copy the formula one more time. Logarithm of the one given base, all base of the one number or variable, it doesn't matter, is equal to the division to thing. Logarithm of the another base of the same number or expression divided by logarithm of this. BB is the same. Okay, you can interpret it. For example, 8 is the old base we have. And B is the new one. New base. So there are many possibilities to face this example. Well, personally, I like that way. Look, you, for example, you manipulate the right-hand side, that part. Okay, the base is 8, and you convert to base 2. And when you have base 2, both logarithm, it's easy for us. Okay, let me try how you manipulate that using that formula. Look, this is logarithm base 2 because the new base I propose is 2. Why 2? Because it's the same base that we have on the left-hand side of the 3x. Remember our expression, this specific problem is 3x no x. And the formula I put x, but in the specific example is 3x. So I need to respect this. Divided by logarithm base 2 again, look, is BB. In our example, the new base is 2. The old base is 8. Divided by logarithm of base 2 of 8. Oh, perfect. I understand now. Okay. I apply the formula. Now I focus in the application for the formula now. Okay. I need to compute that. Logarithm of base 2 of 8. We can use a calculator or by hand. And the calculator, you put log 8 divided by log 2. Okay, because I want to apply one more time the change of base formula, no? In this case, I change the base 2 from the standard, que is 10. It's obvious that the answer is 3, right? The answer is 3. You put in the calculator, verification, guys, 3. By hand is easy also. Look, logarithm base 2 of 8. I have no idea. You convert to exponential. Okay, is 2 to the x equal 8. Here I know that a is 2 to the third power. Therefore, it's obvious that x equals 3. Hand or calculator. Either way, I know that this guy is equal to. Okay, super. CS3, we continue. Entonces, so far, my equation is 1/3 logarithm base 2 of x plus 6 is equal logarithm base 2, this guy, of 3x divided by 3. Ooh, I like that because I see 3. If you multiply the entire equation by 3, 1 by 1 is obvious that this 3 and this 3 is cancelled, and this 3 and this 3 is cancelled. And we have logarithm base 2 of x plus 6 is equal logarithm base 2, wow, is of 3x. Fantastic, fantastic, because almost we finish. Remember, if we have two logarithms and the base is the same, it's because the argument is the same. Because logarithm is also one-to-one function. Because logarithm is also one-to-one. So magically, you convert a logarithmic equation to linear equation. And the solution is straightforward. It's doing 6 is equal to 3x minus x. 6 is equal to x divided by 2. X equal to 3. That's it, no? I need to verify. I need to verify. I need to verify. Verify where? In the original. I need to prove it 3 work or doesn't work. In the original, 1/3 logarithm base 2 of 3 plus 6 should be equal, question mark, logarithm base 8 of 3 times 3. Okay, we focus in the solution of this. Okay, 3 plus 6 is 9. And 9. 3 times 3 is also 9. 3 times 3 is 9. Okay, but I have no idea because it's completely different logarithm, no? So one more time, we apply the same idea. Chain of base formula. This is logarithm base 2 to get the same base to compare, so clear, of 9 divided by logarithm base 2 of 8. But that part I did before is 3. And this 3, and this 3 is cancelled. And logarithm of logarithm 2 of 9 is equal to logarithm 2 of 9. Super true statement. Therefore, the solution 6 is perfect. 6, no, 3 is perfect. It is perfect. Super solution. Okay, I put this. This is no common case. Logarithmic equation with different base. So what is the possibility? Well, the possibility is you have several possibilities. Or you change 8 to 2. Because I think I did that because I consider it easier in my mind. Or you can change 2 to 8, or you can change both to standard. But this is too long, complicated. No, I suppose que no. Okay, one more. All right, one more. 2 more example and stop. Okay, 2 more example and stop. Stop because next time we start the applications. Okay. This is easy. This is easy. Look, log of 3 plus x minus log of x minus 3 equal log of 3. Wow, 3 logarithm we have in this equation. Entonces, what should I do? We move everything to the one side and condense. We can. However, no. I suppose it's much better condensing the 2 logarithms that we have in the left-hand side. In this case, you apply the property 6 because it's minus. No? When you condense in this guy, is like a 3a plus x in the top. and x minus 3 in the bottom. And this is the argument of the logarithm. But professor, I don't understand something. What is the base number? It's missing. You need to know by memory. Okay, when the number is missing, it's because the base is 10. Because we are talking about common logarithm and not specification. You need to be aware for this situation because in the test, sometimes happens that situation. You see logarithm and no specification of the base is because this is common logarithm. Is equal logarithm of 3. Wow, fantastic. One more time, we have the situation in which if you have two logarithms and the base is the same, because by the way, the base is 10, because default, no specification means que 10, it's because the argument of the logarithm is the same. So this is the equation I need to solve. It's linear equation. And you apply cross multiplication. 3 plus x times 1 is equal to x minus 3 times 10. Apply these 3 with the property here. It's 3x minus 9. Okay, and this is the equation. I have to solve it. I have to solve in 3 plus x is equal to 3x minus 9. What I propose you, well, move this stay here. Why not? Minus x, move to the right. 3 stay here plus 9. This is 12. And this is 2. By 2, x equals 6. Boom. I need to check it, of course. I need to check it. Where? In the original equation. I need to verify that this statement is true. Logarithm of 3 plus 6 minus logarithm of 6 minus 3 should be equal logarithm of 3. But this is easy to prove by hand, no calculator necessary. Logarithm of 9 minus logarithm of 3 because 6 minus 3 is 3 is equal to logarithm of 3. Well, many ways to do that. Yeah, one more time you apply the property 6. And the property 6 condensing this in only one. Logarithm of 9 divided by 3. 9 divided by 3 is 3. And logarithm of 3 is equal to logarithm of 3. Super true. The solution is perfect. It's important, guys. The checking is super important. Okay. One more or no? One more. And that's it. I promise. Okay. Remember, I repeat again the idea. We have two important dates. December 10 is due test 4. Online and on paper. And December 13, fine. Don't worry because I sent to you both simultaneously. Test 4 on paper and final together. He said, I sent not this week, next week. Okay. Please. I don't know if you understand or not, but of course I have to turn in the overall grade of you in one specific date. That you have due date, I have also due date. So any delay is horrible. Fix that. Because to fix that, I need to create document, notification the mistake. I know because the student is sick. No. Please don't delay. This is the date. I grade and that's it. You know my way, guy. Yeah? Okay. Okay, let's do in the last one. The last one. Are you clear? Are you clear with the date?
Yes, Professor. Could you please check my email after this class?
I checking, yes. Yeah,
Okay.
I send answer. Si you don't are not clear, send me another email, okay?
Okay. Thank you.
And it's important, guys. It's important for everyone, not for you, for everyone. You check it out in the Blackboard, see your grade corresponding perfect with the idea you have, no? Any problem or any discrepancy, you let me know by email, now here. And I checking, I fix it. See, I make a mistake, no? Because I am human, no? Okay, the last problem, We have time? Yes, we have time. It's natural logarithm of x. Oh, it's a natural. Never I see before natural in the equation. X plus 2 equals 4. Okay, and this problem is natural. Okay, natural is the same. The only difference in natural, the base is e. And e is an irrational number. It is approximately 2.718, infinity decimal place. It's a base. And this is natural logarithm, okay, used in calculus. Okay, now condensing. Condensing natural logarithm multiplication, this expression. And this expression. By the way, I forgot here the parentheses. Never forgot the parentheses. This is x times x plus 2. And the bracket or parenthesis enclose the argument of this. Okay, now this is a crucial moment to change to exponential. When you change to exponential, it's obvious that the base is e. You need to know default que ln is equivalent log base e. And the e and the exponent is 4. And this is the number, guys. It's weird, but it's the number. It's equal to the rest. Is this. And you apply this distributive property, x squared plus 2x. And this look like quadratic equation. Don't be scared with this number because it's a number. That's it. So it's x squared plus 2x minus e to the 4th power equals 0. And you solve it, this quadratic equation. It's obvious that by factorization it's impossible because I don't know what is e. I am not clear, but by quadratic formula always is possible. 1, A is 1, B is 2, and C is minus e to the 4th power. Super. Apply the quadratic formula, minus b plus or minus square root b squared minus 4ac divided by 12. In our specific example, b is 2 constant. This is minus 2 plus or minus square root. Well, b squared is 2 squared get 4. Put it like that. Minus 4 multiplication by 1 is a multiplication by negative e to the 4th power. Divided by 2 times 1. Okay, we focus it in the expression inside the radicals always. Here, over there.
2 squared will equal 4.
And we have plus, because double minus, 4 e to the a to the 4. We cannot do anything, just me. Well, yeah, you can. Because 4 is common factor, I factor out. Sorry. Mistake. Factor out, parentheses. 1 plus e to the 4th power. And when you apply the square root, when you apply the square root of this expression, es obvio que square root 4 is 2. And square root the rest, leave it like that. I cannot simplification this, no, because it's plus. But my solution so far is minus 2 plus or minus 2 radical 1 plus e to the 4th power divided by 2. Oh, look at that. These two is cancelled out if you want. A simplification a little bit is negative 1 plus or minus radical 1 plus e to the 4th power, because these two we can factor out. So you factor out to s minus 1 plus or minus a radical. And these two are cancelled. Because we have nothing in the bottom. Huh? We have two solutions. We have two solutions. The first solution is negative 1 plus radical 1 plus e to the 4th power. And the second solution is negative 1 minus square root 1 minus e to the 4th. This solution doesn't work because it's negative. The negative solution doesn't work because when you try to plug it in the original equation, it's obvious that no. The logarithm of negative number is completely out of the domain. This yes. This is a, you leave it like that, so you want the exam. So you want the approximation, you put in a calculator. When you put in a calculator, the answer is 6 point. Let me check it just in case, because I did before. I don't remember if I do well or not. Let me check it. It's negative 1 plus, this is plus. This is plus here. Negative 1 plus square root 1 plus e to the 4th power. Boom. 6.48 exactly. A ver, es 45, 64, 64, 45, 64, no 61, 64. Yeah. I copy right in the paper, I copy wrong in the board. Here, 64. Entonces, this answer, you have to verification. Yeah, you have, but it's super complicated. Entonces, this is 4. Boom. Final answer. Okay, the checking you are doing like a homework. Is you checking approximately. You plugging in this number in the original equation and verify it's true. Let's do it. Why not? Let's do it. I put in a calculator. Logarithm of 6.45 64 plus logarithm of 6.45 64 plus 2 should be 4. Of course, this is you truncate decimal. Therefore, the answer is not exactly, but it's similar, no? It's a basic. Wait. Before that, why no? You condensing. So actually, this is logarithm of 6.45 64 plus logarithm of 8, because 6 plus 2 is 8, 45 64, and together is logarithm of, let me multiplication, 6.45 64 times 8.45 64. Boom, I get 54. 54.59 79. Okay, should be 4. Let me see if it's true or not. I suppose que no exactly because you truncate decimal, but it's okay. Natural logarithm of that number. Press close the parentheses. The answer is 3.9. 9. A lot of 9. 9. How many 9? 1, 2, 3, 4, 5, and 5. It's obvious it's true. The reason it's not absolutely true is because you truncate the shit. Okay, guys, enough for today. Okay, let me see. Wait. Share. Stop sharing. Do you see my face now? Remember, December 10, test 4. Final test, December 10, 13. End the story. And we finished successfully this semester. Don't forget subscribe in my YouTube channel because I give 5 points extra in each test. Okay, 5 points. It's easy. I checking some students subscribe, but no all students subscribe.